以来掌握，在稍早辉达执行长黄仁勋已经宣布了台湾的这个总部会落脚在士林北投。其实，在先前的时候，东森新闻已经独家掌握到了，其实这个地址选址就有可能会落在所谓的北士科 T10、T18，而这里呢，正是这个星光人寿之前所标下的一个案件。而先前我们也独家掌握到，在过年前后的部分呢，其实这个辉达也已经有和星光人寿来进行一个谈判。过去呢是在讨论所谓的变更设计的部分，但是当然现在也有关于新售到底会不会来进行解约，又或者是说新售以及辉达还有市府之间三方这个契约之间要来进行重新的调整。不过呢，这接下来的一些程序当然是非常的麻烦的，但是呢，其实会落脚在台北会落脚在台北的士林北投。当然可以看到今天台北上蒋万也特地来出席黄仁勋的演讲，或许这也是一个暗示哦。不过呢，其实在这一次的这个落脚在北士科的部分呢，其实在稍早的时候，早盘士林三宝包括了市指、金纺、市电都已经接力亮灯涨停了，所以或许这个辉达的进入，当然有助于后续经济的成长。
NVIDIA has been coming to Taiwan for over 30 years. This is the home of many of our treasured partners and dear friends. Over the years, you have seen NVIDIA grow up and seen us accomplish many exciting things and have been partnered with me all along the way. Today, we're going to talk about where we are in the industry, where we're going to go, announce some new products, exciting new products and surprising products that open new markets for us, creates new markets, new growth. We're going to talk about great partners and how we're going to develop this ecosystem together. As you know, we are at the epicenter of the computer ecosystem, one of the most important industries of the world. And so it stands to reason when new markets has to be created, we have to create it starting here at the center of the computer ecosystem. And I have some surprises for you. Things that you probably wouldn't have guessed. And then, of course, I promise I'll talk about AI. And we'll talk about robotics. The NVIDIA story is the reinvention of the computer industry. In fact, the NVIDIA story is also the reinvention of our company. As I said, I've been coming here for 30 years. Many of you have been through many of my keynotes. Some of you, all of them. And just as you reflect on the conversation, the things we talked about in the last 30 years, how dramatically changed. We started out as a chip company with a goal of creating a new computing platform. And in 2006, we introduced CUDA, which has revolutionized how computing is done. In 2016, 10 years later, we realized that a new computing approach has arrived. And this new computing approach requires a reinvention of every single layer of the technology stack. The processor is new, the software stack is new, it stands to reason the system is new. And so we invented a new system that on the day I announced it at GTC 2006, no one understood what I was talking about and nobody gave me a PO. That system was called DGX-1. DGX-1, I donated the first one to a nonprofit company called OpenAI. And it started the AI revolution. Years later, we realized that in fact, this new way of doing software, which is now called artificial intelligence, is unlike traditional ways of running software. whereas many applications ran on a few processors in a large data center. We call that hyperscale. This new type of application requires many processors working together, serving queries for millions of people. And that data center would be architected fundamentally different. We realized there were two types of networks. One for north-south, because you still have to control the storage, you still have to have a control plane, you still have to connect to the outside. But the most important network was going to be east-west. The computers talking to each other to try to solve a problem. We recognized the best networking company in east-west traffic for high-performance computing, large-scale distributed processing, a company that was very dear to our company and very close to our heart, a company called Mellanox, and we bought them 5 years ago, 2019. We converted an entire data center into one computing unit. And you heard me say before, the modern computer is an entire data center. The data center is a unit of computing. No longer just a PC, no longer just a server. The entire data center is running one job. And the operating system would change. NVIDIA's data center journey is now very well known. Over the last 3 years, you've seen some of the ideas that we're shaping and how we are starting to see our company differently. No company in history, certainly no technology company in history, has ever revealed a roadmap for 5 years at a time. No one would tell you what is coming next. They keep it as a secret, extremely confidential. However, we realized that NVIDIA is not a technology company only anymore. In fact, we're an essential infrastructure company. And how can you plan your infrastructure, your land, your shell, your power, your electricity, all of the necessary financing around all over the world? How would you possibly do that if you didn't understand what I was going to make? And so we described our company's roadmap in fair detail, enough detail that everybody in the world can go off and start building data centers. We realize now we are an AI infrastructure company, an infrastructure company that's essential all around the world. Every region, every industry, every company will build these infrastructures. And what are these infrastructure? These infrastructure, in fact, not unlike the first industrial revolution, when people realized, GE, Westinghouse, Siemens, realized that there was a new type of technology called electricity, and new infrastructure has to be built all around the world. And these infrastructure became essential part of social infrastructure. That infrastructure is now called electricity. Years later, this is during all of our generation, we realized there was a new type of infrastructure. And this new infrastructure was very conceptual, very hard to understand. And this infrastructure called information. This information infrastructure, the first time it was described, made no sense to anybody. But we now realized it is the internet. And every internet is everywhere, and everything is connected to it. Well, there's a new infrastructure now. This new infrastructure is built on top of the first two. And this new infrastructure is an infrastructure of intelligence. I know that right now, when we say there's an intelligence infrastructure, it makes no sense. But I promise you, in 10 years' time, you will look back and you will realize that AI has now integrated into everything. And in fact, we need AI everywhere. And every region, every industry, every country, every company, all needs AI. AI has now part of infrastructure. And this infrastructure, just like the internet, just like electricity, needs factories. And these factories are essentially what we build today. They're not data centers of the past, a $1 trillion industry providing information and storage, supporting all of our ERP systems and our employees. That's a data center of the past. This is similar in the sense that it came from the same industry. It came from all of us, but it's going to emerge as something completely different, completely separated from the world's data center. And these AI data centers, if you will, are improperly described. They are, in fact, AI factories. You apply energy to it, and it produces something incredibly valuable. And these things are called tokens. To the point where companies are starting to talk about how many tokens they produced last quarter and how many tokens they produced last month. Very soon, we'll be talking about how many tokens we produce every hour, just as every single factory does. And so the world has fundamentally changed. We went from a company, on the day that we started our company, I was trying to figure out how big our opportunity was in 1993. And I came to the conclusion, NVIDIA's business opportunity was enormous. $300 million. We're gonna be rich. $300 million chip industry to a data center opportunity that represents about $1 trillion to now an AI factory, an AI infrastructure industry that will be measured in trillions of dollars. And this is the exciting future that we're undertaking. Now, at its core, everything we do is founded on several important technologies. Of course, I talk about accelerated computing a great deal. I talk about AI a great deal. What makes NVIDIA really special is the fusion of these capabilities. And very especially, the algorithms, the libraries, what we call the CUDA-X libraries. We're talking about libraries all the time. And in fact, we're the only technology company in the world that talks about libraries nonstop. And the reason for that is because libraries is at the core of everything that we do. Libraries is what started it all. And I'm gonna show you a few new ones today. But before I do that, let me show you a preview of what I'm gonna tell you today. Everything you're about to see is simulation, science, and artificial intelligence. Nothing you see here is art. It's all simulation. It just happens to be beautiful. Let's take a look. This is real-time computer graphics I'm standing in front of. This is not a video, this is computer graphics. It's generated by GeForce. This is a brand new GeForce 5060, RTX 5060. And this is from ASUS. My good friend Johnny is in the front row. And this is from MSI. And we took this incredible GPU and we shrunk it in here. Does that make any sense? See, this is incredible. And so this is MSI's new laptop with 5060 in it. GeForce brought CUDA to the world. Right now what you're seeing is every single pixel is ray traced. How is that possible that we're able to simulate photon and deliver this kind of frame rate at this resolution? Well, the reason for that is artificial intelligence. We're only rendering 1 out of 10 pixels. So every pixel that you see, only 1 out of 10 is actually computed. The other 9, AI guessed. Does that make any sense? And it's perfect. It's completely perfect. It guessed it perfectly. Of course, the technology is called DLSS, neural rendering. It took us many, many years to develop. We started developing it the moment we started working on AI, so it's been a 10-year journey. And the advance in computer graphics has been completely revolutionized by AI. GeForce brought AI to the world. Now AI came back and revolutionized GeForce. So really, really amazing. Ladies and gentlemen, GeForce. You know, when you're CEO, you have many children. And GeForce brought us here. And now all of our keynotes is 90% not GeForce. But it's not because we don't love GeForce. GeForce RTX 50 series just had its most successful launch ever, the fastest launch in our history. And PC gaming is now 30 years old. So that tells you something about how incredible GeForce is. Let's talk about libraries. At the core, of course, everything starts with CUDA. And by making CUDA as performant as possible, as pervasive as possible, so that the install base is all over the world, then applications can find a CUDA GPU quite easily. The larger the install base, the more developers want to create libraries. The more libraries, more amazing things are done, better applications, more benefits to users, they buy more computers. The more computers, more CUDA. That feedback path is vitally important. However, accelerated computing is not general purpose computing. General purpose computing writes software, everybody writes it in, Python or C or C++, and you compile it. The methodology for general purpose computing is consistent throughout. Write the application, compile the application, run it on a CPU. However, that fundamentally doesn't work in accelerated computing, because if you could do that, it would be called a CPU. What's the point of not just changing the CPU so you could write the software, compile the software, run it on a CPU? The fact that you would have to do something different is actually quite sensible. And the reason for that is because so many people worked on general purpose computing, trillions of dollars of innovation. How is it possible that all of a sudden a few widgets inside a chip and all of a sudden computers become 50 times faster, 100 times faster? That makes no sense. And so the logic that we applied is that we could accelerate applications if you understood more about it. You can accelerate applications if you were to create an architecture that are better suited to accelerate, to run at the speed of light, 99% of the runtime, and even though it's only 5% of the code, which is quite surprising. Most applications, small parts of the code consumes most of the runtime. We made that observation, and so we went after one domain after another. I just showed you computer graphics. We also have numerics. This is CuPy numeric. This is CuPy is the most pervasive numerical library. Arial and Shona. Arial is the world's first GPU accelerated radio signal processing for 5G and 6G. Once we make it software defined, then we can put on top of it AI. So now we could bring AI to 5G and 6G. Parabricks for genomics analysis, Mo9 for medical imaging, Earth-2 for weather prediction, cuQuantum for quantum classical computer architectures and computer systems, cuequivariance and cuTensor, contraction of tensor mathematics, Megatron. This whole row, this whole column here consists of all of our deep learning and all of our libraries necessary for training as well as inference for deep learning. This revolutionized computing. And it all started with all these libraries. Not just CUDA, but cuDNN. On top of cuDNN, there was Megatron, then TensorRT-LLM, and then now lately, this brand new operating system for large AI factories, Dynamo. cuDF for data frames like Spark and SQL. Structured data can be accelerated as well. cuML, classical machine learning. Warp, a Pythonic framework for describing CUDA kernels, incredibly successful. cuOpt, mathematical operations, optimizations, things like traveling salesperson, the ability to optimize highly constrained, large number of variables, type of problems like supply chain optimization. This is an incredible success. I'm very excited about cuOpt, cuDSS and cuSparse for sparse structure simulators. Those are used for CAE and CAD, fluid dynamics, finite element analysis, incredibly important for EDAs and CAE industry. And then of course, cuLitho, one of the most important libraries for computational lithography. Mask making could easily take a month.
目前黄仁勋讲到了 AI 加速运算技术的最新进展，那么演讲还在持续当中，我们马上回来。
Accelerate the computation by 50 times, 70 times.